So now moving on to the next session, the next talk, that is by Dr. Ravi Durvasula on novel larvicides for control of Aedes and Culex mosquitoes. So I request Dr. Ravi, so please take a slide.
Good, thank you very much. It's a pleasure to be here, and I thank the conference organizers for this opportunity. Very exciting and interdisciplinary gathering here. So I'd like to talk to you now about a continuation in part on the theme of aquatic-borne diseases. And I'm going to focus specifically on something that's very relevant here in India, which is the mosquito-borne group of diseases, and some work that's going on in my research lab in Chicago on devising some new approaches to tackle these. Go to the next slide, please. So my overview, I'm going to just touch upon the global impact of vector-borne diseases. As I said, I'm going to focus on Aedes aegypti and Culex, two very important mosquito groups, the role of water sources, the ideal properties of larvicides, and then the new larvicides that are under development. This is a project that's been funded recently by the Centers for Disease Control and Prevention in the US, and it's a 4-year program that's it's a US-Brazil collaborative. Next slide. So when we talk about vector-borne diseases, why do we still talk about them? These have been around forever. They remain a major cause of human illness despite excruciating levels of efforts around the world. Tens of billions of dollars invested in trying to control them, and you still read about 650,000 children a year dying from malaria. That's terrible. It's unacceptable. By the way, that's a huge improvement. It used to be 1.1 million a few years ago. And so we're getting better, but still massive outbreaks of these diseases, and many of them which do affect India and affect this city. These are highly relevant not only to human life. That's a conservative estimate that $100 billion worth of agricultural losses occur because of arthropod-borne diseases of plants. The importance in East Africa of Trypanosoma brucei complex, $2.5 billion worth of loss in the livestock industry. And many of them persist because of a lack of effective vaccines, in many cases a lack of effective and affordable drugs. There are drugs available, but if people can't afford them, they're really not that effective at all. And then, over time, resistance. And we heard a little bit about that in the last talk. Resistance not only to the drugs, but resistance to the pesticides that are used to kill the insects. I've done a lot of work with ICMR in Patna, in the state of Bihar, where there's been a huge campaign to get rid of sandflies using DDT. And it got to the point where DDT became a herbicide and not an insecticide. 90% of the sandflies were resistant fully to DDT. Unfortunately, the plants were not, and the state is losing foliage. This is how bad it can be in controlling some of these arthropod vectors. Next slide, please. So if you look at the burden globally, if you look in the bottom right, 3.2 billion people in the world are at risk for malaria. Again, no, don't change it, please. Very, very important. You look at some of the other diseases, the emergence of Zika virus, Dengue Fever, which remains explosive around the world, chikungunya. These are constant and in some cases endemic, but also epidemic diseases. And when the rains hit in India in a few months, I will bet the house that you're going to get a lot of dengue in the urban areas of India. This is an inevitable cycle of our inability to control vectors and the water in which they breed. Next slide, please. So I'm going to talk about Aedes aegypti. This is a very important mosquito. I think I caught about 3 of them so far in this room. They're everywhere. Okay, I landed in Hyderabad airport and there came the Aedes aegypti. This is responsible for the transmission of 4 very important pathogens. We always talk in the field of infectious diseases and vector-borne diseases about vector competence, the capacity of an insect to transmit a pathogen. This is one of the most competent insects on the planet. It can transmit 4 different viruses very well. In some cases, multiply. Dengue fever, Zika, which has gotten a lot of attention lately, the chikungunya virus, which in the last big outbreak in India affected over 1 million people, many of them in the states of Telangana and Hyderabad and Andhra Pradesh, and yellow fever, which is reemerging now as an urban menace in Brazil. It's a global menace. It's a highly anthropophilic vector. And this is an important point. This is a mosquito that likes us. It likes to be around us. And it's an urban disease. So when we think about water and the nexus between water, health, and urban diseases, Aedes aegypti plays a very important role. It's also a day and night feeder. Those of you who study malaria and the Anopheline mosquitoes, they only feed from dusk to dawn. Aedes will feed constantly. Next slide, please. So here are 2 of the important diseases. The one on the left, Zika virus, what you see here is a young Brazilian child with a microcephaly, which is just means small head, small and misshapen head. And so Zika virus, though it may affect many, many people, in the vast majority, this is an almost asymptomatic disease. You might get a slight rash and fever. But in pregnant women who get Zika virus, and the timing, if you remember, when Zika virus hysteria rose shortly before the Rio de Janeiro Olympics, it couldn't have really been a worse case. So pregnant women and people traveling in and out of the endemic zone of Brazil, where it first hit, were most affected by this. There have been very few cases of transmission in the United States, although the U.S. is now preparing for it. I think many people, including the CDC, would say it's inevitable. There have been over 2,000 cases on the island of Puerto Rico. There have been cases now in many areas just south of Florida. No, back please. Thank you. Dengue fever, this is something that in India it's called dengue fever, but this is something that's highly, highly known and recognized, a severe illness. In its initial forms, more fever, a lot of body aches, maybe some rashes. It's the reinfection with certain serotypes that leads to devastating hemorrhagic disease. And people die of this disease each year around August through September, October. The city of New Delhi experiences thousands of cases, and I know they're around the country. So this is an important one. Next slide. 2 other important diseases transmitted by the Aedes complex. Chikungunya, many people have heard of it, know of it, or have had it in this part of the country. A disease characterized by fever and arthritis, arthralgias, and a rash. And yellow fever, which is a deadly disease. The only one of these 4 that has a vaccine available, not a very good one. This is a disease that's endemic in parts of Africa and South America. And most worrisome is the resurgence of urban yellow fever in Rio de Janeiro and parts of Brazil, which has occurred in the last couple of years. So these are some terrible diseases transmitted by Aedes. The Culex mosquito is something that we pay a lot of attention to in the United States. So the 2 main ones are pipiens and tarsalis, likely introduced. The mosquitoes themselves and the viruses were likely introduced through commercial cargo in the United States, and the mosquito itself is also competent for St. Louis and the equine encephalitides. Next slide. Now I want you to see this slide, the spread of the West Nile virus in the United States. I was living in Connecticut at the time that this virus began to become endemic in the New York City area. So if you had to pick the worst place in the United States for a disease to make its appearance, it would be New York City, given the density and the migration that goes in and out of the New York and tri-state areas. So when the virus first showed up, and then it became indigenized in Culex, it spread all over the country. And this is a disease which, by and large, is a disease causes fever and people can get over it, except in the elderly, where you may get profound neurologic disease and death. Next slide. And if you look at on the right there, the spread of West Nile virus, what's shown on the left is Phoenix, Arizona. And those who have been to Phoenix, Arizona, that's how it looks like. It's right next to the Sonoran Desert. So this is a dry area. And I just mentioned that we're talking about diseases associated with water. And this is one of those unique things that you see probably only in the United States, and that is an outbreak of a disease because of people with swimming pools. And literally the swimming pools in Phoenix became reservoirs for culex, and the disease began to spread. So really it took off. Next slide. And so really, what we're going to talk about now is water. This is all about water. If you get rid of standing water, you get rid of these diseases. This has been known since the days of the ancient Romans. It's been actually known in the ancient writings of India. It's just, unfortunately, it has not been practiced, it has not been sustained, and what we have now is a mess. So mosquitoes need water, and you see the eggs are laid on the surface. The larvae live inside, and they're completely aquatic. The pupae rise to the surface, from which you get more adults. So it's all about that water. Next slide. So when you want to get rid of mosquitoes, and this is what's interesting. I was at a conference in Spain where the Bill and Melinda Gates Foundation were discussing ways to tackle mosquitoes. And now, public health officials, industry, philanthropic organizations are starting to think about larvae and the water. If you look at where the majority of efforts are placed to get rid of mosquitoes, it's trying to get rid of the mosquitoes themselves when they're flying around. So when you start off with the scene on the left, people walking around with handheld blowers shooting chemical pesticides into the air, I would say it's too late. Right? Those things can move. And then when you do what's on the right here, and I remember when West Nile virus hit New York City, I said I was living in Connecticut, 60 miles away. There were scenes from our state parks in Connecticut with planes going overhead dumping pesticide. That's way too late. So the challenge to get rid of some of these is to go earlier in the cycle. Next slide. And so you control the breeding sites. These are basic principles of public health. These are the kind of posters that showed up in the Southwest in the United States on how to disrupt the life cycle of these mosquitoes. You see these kinds of posters in India in different languages. I've seen these in Central America. I've seen them in Brazil. It's all about the breeding sites and trying to get rid of the water from those areas. And I said it's been known but not well implemented. Next slide. And this is interesting. It says reality bites. This is from Times of India, and it's about dengue cases and all this. And I thought it was an interesting slide because I found this other slide of All India Institute of Medical Sciences in Delhi, which is the premier medical institution of India. Premier. A few years ago, there was a massive outbreak of dengue fever in Delhi, and they traced the breeding sites in this part of South Delhi to the front lawn of this institution. So the best medical institution in the country was a breeding site for Aedes aegypti because water was not controlled and the patients were coming inside. So yes, reality does bite. Next slide. So aquatic pesticides, so one way to do this, you can say, is go around in a boat and spray pesticides or put pesticides into the water system. In Chicago, there's one of the largest mosquito abatement programs in the world, and the use of these permethrins and their derivatives, directly into the water system, treating over 35,000 to 40,000 water containment areas. That's one way to do it. But there's lots of problems when you put pesticides into the water. And, you know, it's just that it's not that the water, as we've learned already and we're going to keep learning, it's not that it's pure. There's all kinds of contaminants. There's all kinds of chemicals that leach into water. And by adding more pesticides in there, the variety of toxicities is incredible. You know, there's a statistic that I tell our medical students. Over 50,000 farmers a year die because of the pesticides that they're spraying on their plants. And an interesting phenomenon, when genetically engineered cotton began to make its way across the world, you know, it used to be that farmers would take the pesticides and point them down because the plants were lower. The more engineered products grow taller. So when they point the pesticide canisters, it's straight ahead into the wind, and that wind blows the pesticides right into their lungs. So the number of neurologic, respiratory, and you know, other disorders that occur from these is dramatic. So how can we make, and this is really what I want to just spend the rest of the talk on, is the idea of a new larvicide. And how can we come about with something that's environmentally friendly, non-toxic, and easy to make? And so if you think about what would be a green larvicide, okay, one that would tackle the larval stages of those mosquitoes and not cause all the problems, it would be cheap, non-toxic, easy to produce, targeting mosquito larvae, easy to apply, biodegradable, amenable to continuous delivery, unlikely to select for resistance, not having other effects, and really being able to target mosquitoes across the water column because the larvae swim up and down. So next slide. So this is really, and I'm sorry this kind of shrunk in here, but so what our lab has done, and this is now a patented technique, and it's going to be developed commercially. Right now it's been funded, as I said, by the CDC. Is we take something, and this is a medical student in my lab who thought of this, Scott Matthews, brilliant guy. He said, let's take yeast. You can go to any corner store in the neighborhood and buy baker's yeast. It's what you put in bread. Take the yeast, heat it to 40 degrees, co-incubate that with essential oils, and there are many of these, cinnamon, lemongrass, clove, orange, things that are used. These are natural derivatives. Cool the yeast. Now, there are a few proprietary steps in there which I did not mention. As I said, this is being commercialized. But essentially what you get is a capsule. You get a yeast cell with an oil in the middle. And the larvae of Aedes aegypti and Culex contain the enzymes that break the yeast cell and open up the oil. So the whole idea is we're going to take a non-polluting, environmentally friendly, and safe oil and deliver it using the food of the larvae, which is yeast. They love this stuff. They preferentially eat yeast. So that's really the technology, and as I said, a few steps in there of washing and coating, which are a bit unique. But the goal is, can we apply these into water chambers and kill the larvae? All right, next slide. And so I'm just going to show you this is all data which we recently presented in New Orleans at the American Society of Tropical Medicine and Hygiene. The manuscript is in preparation. So this is a study done with stage 3 larvae of Culex pipiens. And we did these studies with clove oil. This is an extract of clove. And so when we used, you can see on the axis, it's a little unclear, but at close to 40 milligrams per liter, that's the concentration, we get 100% killing of Culex. This is a very easy concentration to attain. It costs pennies to do this. We use mortality as an endpoint. In the 4 slides I'm going to show you, they look at mortality, but significant morbidity, slowing down the larvae, their inability to eat, and sort of a moribund state were also observed before the full concentration. And you can see that generally we're talking about 24-hour kill curves. Next slide. This is the same Culex with orange oil. This is the oil, if you ever take an orange peel and you squeeze it, you get the stuff that sprays out, and there's a little oil. That's what this is. So you encapsulate that, much more effective, concentrations down to 20 milligrams per liter. Again, readily available, and we can easily make these. Next slide. This is a study, those two studies I just showed you were done at our lab. At the Uniformed Services University in Bethesda, our partners have been looking at Aedes aegypti. And these are stage 3 larvae, and this is a kill curve with orange oil. Again, we're getting down to about 30 milligrams per liter to get 100% killing. Next slide. And then, back there. And this is going on at Fiocruz in Rio de Janeiro in Brazil. So this study is going on at 3 sites now. And orange oil is being used, and we're validating it in a local Brazilian population of Aedes aegypti. Again, almost identical results to what we got in the United States at Bethesda. So next slide. So what we have right now, and I will tell you, this is still laboratory phase development. It's still being done in smaller containers. It's not spatially accurate, but it's a 4-year program, and we're at the stage now where we're starting to do simulated field trials in and around Rio de Janeiro. And Rio, as you know, is like Delhi, one of the epidemic hotspots in the world for dengue and chikungunya. Zika, of course, is a problem in Brazil. You may have heard recently there were 125 cases in the state of Rajasthan. So Zika is here, and we need to prepare for it in India as well. Yellow fever, thankfully, is not here. But this is an area where these trials are extremely important, and we're going to move it on into larger spatial settings. Right now, there's a patent pending on it, and we're working on commercial partnerships for the development of this technology and the large-scale applications of it. The next stage of this project, which I think is equally interesting and could be exciting, will be the applications of this to anopheline mosquitoes. A little bit harder than Aedes in terms of habitat control, but if you can get the anophelines, of course, that's malaria. So those are the next steps. Next slide, please. I think that's it. So really, just in summary, I just want to stress the importance of water systems for infectious diseases, specifically mosquito-borne, and certainly these are relevant concepts, and the use of chemicals that are toxic to humans, to fish, to other organisms is probably not going to work in the long run, and we do need to work toward green pesticides. And stay tuned, the green larvicide may show up in India sometime soon. So thank you for your attention.